Today we are going to practice both identifying the type of radioactive decay as well as balancing radioactive equations. So here we have our first example. We have uranium-232 and we have it decaying. And this type of decay, since we have this helium with 2 protons and a mass of 4, meaning it has 2 neutrons, this is going to be alpha decay. I know that from this, okay? And I just need to see who it's going to turn into. Now remember, the left side and the right side have to be balanced numerically. So 232 minus 4 will be my new mass, which means that it is going to be 228 as my new mass. And my new proton number is going to be 92 minus 2, because I need both sides to equal the same thing, so that would give me 90. Now I just need to figure out who has a atomic number 90. And if I look on the periodic table, I see that thorium has a atomic number of 90. Now here I have another type. This one, I don't know what the actual radiation is, but I can figure that out based off of what I have present here. Now I see that my mass does not change. That means this is not alpha decay, because my alpha decay, my mass would change for my newly produced element here, but my number of protons changes and it actually increases, okay? That means that this is going to be my beta decay, and beta looks like this. Gamma decay would not have changed my proton number and it would not have changed my mass. So since my proton number increased, it had to be beta. Here's my third type. I see that my mass went down by 4 and my protons went down by 2. This looks like alpha to me. This next one, I see that I have a mystery beginning element, and it underwent beta decay. That's what this is. And I produced nickel 60. Now the mass is going to still be 60, but my proton number is going to be 28 minus 1, which will be 27. And so I need to find the person that has the atomic number 27, and that is going to be cobalt. So I'll go ahead and just say that this is cobalt that underwent beta decay and it turned into nickel. Okay, my next one here, I have sulfur. It's going to undergo beta decay, which means that my mass will not change, but my protons will increase by 1, because 17 minus 1 is going to equal 16, and we have to have the total on both sides be the same. So now I just need to figure out who has a proton number of 17. That is going to be chlorine. And we can keep going. So the next one we have uranium-239. It's going to be undergoing gamma decay, which means that my mass is going to remain the same, and my protons are going to remain the same, which would make my actual element be the same. So this is going to be gamma. It doesn't actually change a whole lot, it just releases a lot of energy. Last couple here, instead of having things that we just need to fill in, just one, we have our hints here of what we are going to be decaying with. This one has a beta decay, which means that my mass will not change, but my proton is going to increase by 1, because 21 minus 1 is going to equal 20, and I just need to find out who has a proton number of 21. That is going to be scandium. And I'm done. We have polonium-210. It's going to undergo alpha decay. and we just need to subtract and figure out what's gonna happen. So 210 minus 4 is gonna give me 206 as my new mass, and 84 minus 2 will give me 82 as my new proton number. And now I just need to find the person that has the atomic number 82, which is going to be lead. And I'm on to my last problem. Here I have sodium. It is going to be undergoing beta decay, which means that its mass will not change. And the proton is going to increase by 1. So what's 1 plus 11? Oh, well, that's 12. 12 minus 1, that equals 11. These are balanced. I just need to find who has the atomic number 12, and that is going to be magnesium.